Hey, my name's Scout, and this is going to be the video demonstration for the Fluent project. We're going to get started. We're just going to go over here. First of all, make sure that you didn't just type Fluent in, because that's what I did. I spent about 30 minutes making sure I'm in Workbench. But once you're in Workbench, you're just going to drag the Fluent tab over here. You're just going to drag it in one of these green squares. I'm gonna go ahead and click geometry. Make sure you come over here and select 2D. Then we're gonna go to geometry, right click that, and then I like to use design modeler. That's kind of how I learned it. It's just the easiest I've seen. So we're gonna click that. Now we're in Fluent, the design modeler. So we're gonna go over here, click XY plane, make sure it's straight. So the Z-axis is what you're looking at. And then we're gonna go over here, click sketching, the rectangle, and then we just click and drag. And then to get it where we want, we're gonna go to like the dimensions we want. We're gonna go to dimensions tab right here. Click on horizontal, connect these two vertices in the edge. Try that up right there. And then we can go to vertical. Put those right there. Try that out. And so now we have these dimensions that we can alter. Basically, I think I used 750 millimeters, and then 1/150th of that is 5 millimeters. And so now you can see we have our pipe, kind of. It's the rectangle of it. Our next step is going to be going up here, going to concept, surface from sketches, and then we're going to go here, box select, we can select our whole object, click apply, and then let's go over here, click generate, and now we have that. So after we're done with this, we're just gonna close design modeler. And then now that we have some geometry, the mesh is gonna go from a question mark to this little green arrow circle thing. And then we're ready, we can click mesh, double click that. So now we're in meshing. First thing we're gonna do is go over to here. Actually, we're just gonna hover over this, right click it, gonna create name selection. Let's name this upper wall. Then go over here. I'm gonna do the same thing with all of these. Just name them just the lower wall. It's gonna be our inlet. And then over here is gonna be our outlet. Now we're gonna go over to mesh, hit insert, sizing. I'm gonna select these two edges, hit apply over here. Then we're gonna go to the type, go to number of divisions. I think I selected around 2000 here. Just gonna make sure it's like accurately covering your entire like line. I'm not an expert in meshing, but I found that this works. We're also gonna make sure down here, gonna go to capture curvature, set that to no, and then behavior, make that hard. After we're done with that, we're gonna go to generate, just click this, and you'll have to wait a second. We'll come back to that when it's ready. So now that we're done with that mesh, we're gonna go over here, do the same thing, but with these edges, the inlet and the outlet. Go over here, make sure they're both selected. Then we can go over here and click apply, make sure it says two edges. And then we're gonna do the same thing as we did with the last, but it's like number of divisions. And then instead of 2000, because that's how it's like really long, I think I used about 100 here, which makes sense, given like the aspect ratio between the two. Then we're gonna go here, capture curvature off, and then behavior, do the same thing. You're gonna do the same thing. You go to generate, click that, and it should take a second, and I'll meet y'all when it's done. So now that that is done, we can go over here, click insert again, and we're gonna do a face meshing this time. We're just gonna select this face that we made, click apply, and then generate mesh, and then this one's normally pretty quick, so I don't think we gotta leave. Okay, so now that that is done, we're all good in the meshing zone. Just look, we can also see our name selections over here, upper wall, lower wall, inlet, outlet. Those are gonna be important. It helps us when we're in the next step of the process, which is the setup. So let's go there. So now that we're back in the workbench, we're gonna go over here, click update. And now we can move on to our setup. So in the options here, I clicked double precision when I did it. I'm not exactly sure what that means, but in the tutorials that I watched, they recommended that. And then we can go here and click start. So now that we're in the setup stage, everything about the geometry and the meshes are gonna be the same for the 3 types of flow. So the one I'm gonna show you how to set up now is gonna be the Poisseuille. So the first thing we're gonna do is go over here to models, double click that. And then we're gonna hit laminar here. We're gonna make sure, go over here to materials. I don't think you don't really have to change this. I just set it to 1.8 to make the math a little easier, but we can keep it like that. The density is fine as well. Then we're gonna go to boundary conditions. In the inlet, we're gonna double click this. It's gonna be basically we're setting like the velocity of the air going into the pipe. I think when I did it at 8 meters per second. Click apply there and close. And then on the outlet here, we're just gonna select this. Just hit prevent reverse flow. This will help our simulation. Hit close. And for our walls, I'm just gonna go here and make sure they're both stationary because it's the type of flow that we're analyzing, and there's no slip shear condition. Same with the upper wall. Let's check that. Yep, all good. Next thing we're gonna do is go down to here to make sure everything matches what we have in the other values. So like the viscosity, I didn't change it, so it should be the same. Yeah, we're gonna click compute from inlet, and then the reference zone is the surface body. Now we're gonna go here to initialization. Keep it on a hybrid initialization, go to more settings, and then 10 iterations is fine for the initialization. We're gonna click OK, and then initialize. You'll see this kind of happen. Everything looks fine. It's all done. And then after that, we can go here, double click run calculation. I set my iteration count to around 200, 150 for the different simulations. We can go ahead and just hit, I'd say 150 is on the lower end for this. And then we can hit calculate. Just wait for that to complete. And then we go here and go to our results, double click that. So first thing I'm going to do, go over to the z-axis, click that. So we have this head-on view. It looks a little weird, probably not what you're expecting, but there's just a little bit more we have to do, and then everything's going to turn out fine. First thing I did when I got to this part, I just hit the contour. I'm going to leave this contour 1, just so I like made sure I did my simulation right. here, we're gonna make sure the symmetry is 1 here, or like the location is symmetry 1. We're gonna go here, make sure our variable is velocity, and then the number of contours, I set that high because if you don't, it's gonna look real choppy. So I set that to like 100. And click apply. Alright, and now it looks like something's going on. This is like the gift after all the work that you actually see you did something. So I'm gonna go here, just pan. So we can kind of see here it's developing into our laminar flow. You can kind of see the boundary layers of the fluid. So it starts at like a very low velocity by the wall and then gradually increases. Then towards the end, it's pretty complete. It's laminar flow, the highest velocity in the middle. Yeah, looks like it should. What I did for my project is I went up here actually and I made a vector like contour kind of viewer. Then you're gonna go down here, select symmetry 1. I'm gonna turn the contour off really quick. Sampling was vertex, equally spaced. And then I think I made mine around 50,000. Make sure it's velocity. For the symbol, I used a 2D arrow, and then I made it really small because there's a lot of points. Then I go over here, click apply, and you can kind of see it looks a little weird. You do have to mess with the settings a bit to get the visual that you like. But you can see it has these vector arrows. The ones in the middle are really big. The ones over here are really small because the velocity is small. But yeah, that's kind of how you make that vector field. You can go over here, see the transitioning flow. Also gives you like a good view. These arrows start to get bigger and bigger as you go across. Just a good way to represent the velocity of the flow, I guess. I'm also going to show you how to make your charts for like the velocity profile of the midline and the end line. So right here, we're going to go to line. Okay. And then what we can do, we're gonna set the first point to halfway through, like the x value is halfway through. So since we made it 750 millimeters long, we gotta do 0.375. So 375 millimeters. Same thing for this bottom point. And then our top height is gonna be 5 millimeters, which is the height of our pipe. We can go there, click apply, and then we should see, yep, about halfway through. Oh, yeah. Right here we can see our midline. We could turn off this vector. We can kind of see it better. Right in the middle of our pipe. And then we can also make an end line. Like over here, set it, since our thing was 750 millimeters long, this is what I saw in the tutorials when I watched them, just make sure it's a little bit smaller than the length of your pipe. So 0.749 meters, 749, yeah. And then same thing with the height, make this top one 0.005 meters. And then, oh, one thing you gotta make sure of, turn the samples up. It's defaulted to 10. I made this one 100. I gotta go and change that for the other line. Let's go here. Then set that to 100. And then now what we can do, which helps us like analyze the velocity. We're gonna make a chart called velocity profile. Come down here, go to data series. This one we're gonna name midline. The location is gonna be line 1 because that's our midline. Custom data selection. The x-axis is gonna be our velocity. And then the y-axis is just going to be like the height of the pipe. Click apply. And there we go, you can see that. And you see this would be like the bottom of the pipe at 0 meters. This is 5 millimeters, so that's the top of the pipe. And it's about what we would expect, this kind of uniform. It looks exactly like we would expect with the highest velocity in the center of the pipe. And then we're going to go ahead and add our ends line, velocity profile, line 2, and the same data selection. No, it's going to be Y. And as you can see, they do mostly overlap, but the end line is going to have a bit higher velocity. It's just because it has more time to actually develop that laminar flow. And yeah, that's how you make the chart. So since I already showed you how to do the post analysis for the Poisseuille flow, that's going to be the exact same procedure for the hybrid and the Couette flow. So now I'm just going to go ahead and show you my setup parameters that I did for the Couette and hybrid flow. So this is the Couette. We're going to go here, make sure that this is selected to laminar, like it was in the Poisseuille. We're going to go over here to our materials. And then I did change the velocity or the viscosity for this because this one was a little hard to get working. These are the values that I've found to work. So yeah, if you want to use those. But then you come down here. You're going to go to boundary conditions. Our inlet, this one's going to be different. You got to make sure it's a pressure inlet. So how you're going to do that is right click it, go to type, and then make sure it's initially selected to velocity inlet. You got to make sure it's on pressure inlet, and then we're going to double click it. Keep all of this the same, and then you're just going to check this box, prevent reverse flow. And then we're going to go here to our outlet. We're going to make sure that it's a pressure outlet, which it defaults to, and then prevent reverse flow. Make sure that's checked. Then we can go to our wall, and this one is also different from our Poisseuille flow that I showed you earlier. I'm going to go to lower wall first. This one's not going to be moving. This one's going to be like the stationary, so we just make sure it's stationary, no slip, everything's the same. And then our upper wall is going to be different. So for this, the speed is going to be 5 meters per second. You got to make sure it's selected the moving wall, and then you can adjust that. And then keep the no slip condition. Yeah, and then you click apply. I'm not going to because I already did. But now that we have these, go to reference values. Make sure you compute from the inlet. And then we're going to go down here and set up our initialization. This one took me a while to get the initialization right. I'll show you how to do that. I just kept it the same at 10, and then I just hit initialize. And so you'll see the error message it gives. This was a problem I couldn't get past for my simulations. What I ended up doing is that even though it says the convergence tolerance wasn't reached, you can still run the simulation. I figured that out after a lot of trial and error. But yeah, so don't worry, as long as I think it's about this reaching this number, which it doesn't, but it gets pretty close. So it worked for me. Next thing you're going to go do is hit run calculation. I set my number of iterations to, I think when I first did it, it was like 150. Just make sure it's about in that range so you get accurate results. And then you're going to go ahead and click calculate. So after you're done running that calculation, you're going to go ahead and do the same steps that I showed you with the Poisseuille flow. where you can analyze your results. So putting that contour on there, the vector like field contour, and then analyzing the velocity profiles. So now that we're done with the Couette flow, after you're done with that calculation, you can go ahead and go through the steps that I showed you with the Poisseuille flow and the post analysis. Yeah, just make that contour, go ahead and make those lines so that you can use them for the velocity profile chart. It's the exact same process. But finally, I'll show you the hybrid flow setup. So we're gonna go over here, same thing, double precision, click start. So now that we're in the setup, we'll go ahead and show you what I did for the settings. Make sure this, again, is laminar. It's going to be the same thing for all the setups. Go to materials. I'll show you the parameters that I use. This one was a little bit easier than the Couette. I didn't really have to change much. I just set it to 1.8 E -5, and then kept the density the same. Then we're going to go here to boundary conditions. Our inlet is going to be a velocity inlet, so that's fine. It'll be the same. I set my velocity to 3 meters per second. I found that this one worked with the velocity of the moving wall that I'll show you. Keep that the same. And then we can go over here, our outlet. We're just going to go ahead, do what we did for the other ones, say per event reverse flow. And then we can go over to the wall. So our lower wall for this is going to be stationary. Make sure everything's the same. It should be default like this. Yeah, stationary, no slip, close that. And then the upper wall is a little different. I'm gonna keep the no slip, but this one's gonna be moving as well. I set this to 2 meters per second. I kind of found that that one worked. Keep everything else the same. And then we're gonna go to reference values here. I'm gonna go to compute from, actually, no, I didn't change that. But make sure the reference dome is surface body. And then you can kind of see these, they match up to the fluid density. And then the next step, you go to initialization. I think I might have done 15, 20 for this one while I was like setting it up, making sure all the settings were right. But you can just click initialize. And there we see that. This one takes a little bit longer than the Poisseuille, but it's pretty quick. So now that that's done, you're gonna go over here and double click that run calculation. Yeah, for this one I did about 150 iterations. Just make sure you have enough of those, 150 to 200. I found that that kind of works. And then yeah, everything else is the same. Click calculate. Now that you know how to do that, and I've shown you the post analysis for the Poisseuille, that's gonna be the same for this one as well. Just make sure you use that vector contour, and then make those lines so that you can analyze the velocity profiles through them. And yeah, that about wraps this project up.